All right, guys, welcome to today's class. So let's get started with our homework. So the first one on our homework is problem 17. Every camper at Camp Echo is required to take exactly two of the three craft classes offered. One summer, 47 campers took the basket weaving, 59 took cabinet making, and 34 took pottery. How many campers attended Camp Echo that summer? Well, we can notice that since every camper at Camp Echo is required to take at least two of the three craft classes offered. So we can try to calculate which ones got took two. So they're probably going to be, if we were to assume that there are 47 and 59, 47 was in that, we would have this left over. So you want to find the perfect combination, right? So how do we approach this? Let's draw a Venn diagram because this could help a lot. Alright, let me draw a better Venn diagram. Alright, this will do. So we first know that nobody took three classes. So we might as well shade off this region. We don't want this region. The Venn diagram then becomes, we just delete it and just becomes this. Because there is zero, so it's just going to be those three circles intersect at this one point. We also know everyone took two classes. So what there is left is this, and this. So it's just these two areas. Three areas. So these are basically the exactly two sections we're going to be talking about. So, okay. So basically what we have to do is just solve for these areas. Let's just write a system of equations. We can let x plus y equal 47. Meaning that people that took basket weaving from pottery and basket weaving pottery basket weaving and pottery and basket weaving and cabinet making is going to be X and Y respectively. So I'm going to just write B plus P equals X. B plus C equals Y. And then the last one is just going to be cabinet and pottery. And get X plus Y equals 47. We also can get Y plus Z is 59. Then X plus Z equals 34. So if we add everything up together, this will give 140. Or X plus Y plus Z is 140. We have two times of that. And then just dividing gives us X plus Y plus Z, which is our desired result because we're trying to find these areas shaded. Let me shade in black. These areas that are shaded. Because they're counting exactly two. Right? So what we then have to do is just divide by 2 to get our answer of 70. Right? Let's move on to problem 18 now. In a class of 20 students, 5 like to go camping and 10 like to ride bikes. What is the greatest possible number of students that like to do neither? Well, how do we maximize this? Well, we can minimize this. Let's think about how do we minimize it. So we can minimize this by making the go camping people and riding bikes people mutually exclusive, or saying that they don't have any intersection. There's no one that likes camping and bike riding, right? So from there, we can get that 5 is the minimum. We can do the exact opposite thing for get the maximum, which means that there all 5 of the camping people love riding bikes also. So there's gonna be 10 people that like 10 people in total that chose those activities. So which means that 10 people chose neither or A, right? Let's move on to problem 19 now. There are 52 students in a class, 30 of them can swim, 35 can ride bicycles, and 42 can play table tennis. At least how many students can do all 3 sports? Alright, so notice that we can just add everything up first. Let's do that. It gives you 107. We can then notice that we can make sure every student in the class has at least done it twice by subtracting 252s from it. Alright? We just subtract 104 and get 3. And then we got 3 people left. 3 students left. 3 students that can be chosen to do any 3 can be done. Any 3 can do 3 subjects. So there's only 3 students. And that's just basically the answer to the question because we were asked how many students can do all 3 subjects. And this is the minimum because we made sure everyone can do at least 2. And there's only 3 students, 3 spots remaining to give to 3 students to get them having all 3. Right? So the answer to this question is just D. All right, let's move on to example 19. In a class of 42 students, 18 students are in math club, 5 students are in both math club and science club, and 14 are in neither. How many students are in the science club? I'll let you guys have a try on this question and tell me your answer through chat. And private message, please.
You put it back on, I can't see it. I can't see the answers.
Well, let's get started with this question. So basically, how do you approach this? Well, first off, note that there are 14 people that are in neither, or 14 students that are not going to attend this clubs at all. Subtracting that from 14, 42, 42 minus 14 is just 28. Right? Now we're just left with a simple PIE equation. Alright? So from PIE, remember from before, and talked about last sessions, basically it's 18 plus, man, yeah, it's 18 plus the people are in science club, the amount of people in science club, including the math club and science club people, would let denote it as X minus 5. Because we're taking the math club set and we're adding the science club set, and then we're subtracting the intersection. So we're making sure that we're counting each one once. And this should give us 28. Just solving this equation should yield us the answer of X equals 15, or there are 15 students in the science club. Alrighty? Okay, let's move on to example 20. A and B are sets. If A contains 6 elements, B contains 8, and together A and B contain 10, how many elements in A are also in B? Another word for to say is that what is the intersection of A and B? Let's guys have a try on this question and tell me your answer to chat. Alright, let's get started with this question. So basically, if A is equal to if A contains 6 elements, B contains 8, together A and B contains 10, well, just apply PIE, which is just 6 plus 8 minus X, which is just equal to 10. This gives us 14 minus x equals 10, or x equals 4. Right? So the answer to this question is just 4. So let's get started with this question now. Example 21. So basically, 96 girls were surveyed at Euclid High School. There were 48 softball players, 45 track athletes. If 1/6 of the girls surveyed did not play either sport, how many girls played both sports? I'll let you guys have a try on this question and tell me the answer through chat in private message, please, not in the main. Alright, let's get started with this question. We Let's just look through. 96 girls were surveyed. If 1/6 girls surveyed did not play either sport, how many girls played both sports? 1/6. That's just 16 girls. Which is 96 divided by 6. Right? 16. Subtracting that from 96 is just 80. So the total amount of players is just, athletes is just 80. We can just apply PIE again. Let the intersection amount be X. Oops. Yeah, it's basically X. And let that equal to 80. Adding this up, these two gives us 93 minus X, which is 80. Just do your subtraction, we get X equals 13. Or the answer is B. Alright? Let's now get started with example 22. 100 students take science and math. If 73 students take science and 90 take math, how many take math but not science? Unless you guys have a try on this question and tell me your answer to chat. And private message. Alright, let's get started with this question. As I taught you out before, please check your work carefully. So let's get started. There are 100 students in the school, and there's and 90 take math and 73 take science. That's 90 plus 73 in total. But we have extra surplus of 63. If we let x be the intersection, get x equals 63. So it is not 73 as the intersection, it's 63. So please check your calculations carefully. Alrighty? Now, once we get x equals 63, we do 90 minus 63, since we want to find how many take math but not science. This gives us 27, which gives our answer of B, or 27. Most of you guys are getting it wrong on this part or on this part. You either did the subtraction not carefully on the PIE part, and 90 minus 63 equals 27. You might have misborrowed for the 90 minus 63 one. Either way, please check your work and be careful about your calculations, since silly mistakes can cost you a question or maybe a test or maybe more. Anyways, let's move on to example 22. 100 students at a certain school take science or math. If 73 students take science and 90 take math, how many take math but not science? I'll let you guys have a try on this question and tell me your answers through chat. Let's move on to another question, since this was actually the exact same. Let's move on to example 23. In a class of 500 students, every student liked at least one for three kinds of music. 260 like classic, 260 like jazz. I'll write it down. 75 like classical plus rock. 130 like rock plus jazz. 45 like, oh, let me make my writing better and less messy. Alright, so the question is, how how many only like rock? Okay. And these are the answer choices, alright? I'll write them now. 190, 110, 255, 390, 45. I'll let you guys have a go with this question and tell me your answer through chat. Anyways, please chat in private message and do not spam the public chat, please. Or I'm gonna have to close it. Right? Anyways, let's try to do these questions. This question. So we approach it with the normal PIE method. Alrighty? So how do we do this? So basically, using the normal PIE method, let's just let X be the number of rock people. Not since this question says only like rock, we're probably gonna have to subtract some numbers from it, right? Let rock equal to X. From applying the PIE method, we get 260 times 2, because there's two 260s, as you can see. Right over here. 260, 2260 plus X. Righty. We're gonna have to subtract these two. But we also have to subtract 115 because I forgot to add it in. How are doing quickly? It's rock and jazz. So my bad. 100% my fault. We have to subtract 75, 130, and 115. All right? We gotta subtract all of that. And then we're gonna have to add a 45. And this is gonna equal to 500. Now I've already done the calculations. And I got X equals 255. So y'all were on the right track. So most of you got up to 255. But then we had to subtract some things and add one thing, right? So it's not 255. So we have to subtract. Because this is rock people, but they have the intersections. But we don't want intersections. We just love only rock. Okay? So we have to subtract rock and jazz. Let's subtract what rock and jazz. Oops, also misread this part. Anyways, we have to subtract rock and jazz. And then we also have to subtract classical and rock. So if the 255 minus uh 75 or classical and rock and jazz plus 115. This is gonna give us a total subtract of 190 to get 65. Okay, this equals 65 right over here. A new color, 65. Now we have to add in 45, which like all. Why? That's because it's because we counted it twice and we subtracted it twice. So we're now left with 0. We didn't count it any time. I mean, we subtracted it twice than normal. So we're at -1 now. Since we counted it once, we subtracted it once from the rock and jazz, and then classical and rock. We subtracted it twice. So we're now at -1 of those. So we have to add in back another one to count for the fact that we subtracted it twice. So we have to do 65 plus 45, which just gives us 110. So the answer to this question is just 110. We're ready? So the answer is 110. All right, let's do a new thing. We're going to be talking about permutations. A permutation is an arrangement or a listing of things which order is important. A combination is an arrangement or a listing of things in which order is not important. To definition. The simple factorial defines as this follows. 0 factorial is 1. N factorial is the multiplication of n to 1. As you can see, these are the few examples we have over here. These are some examples. And this is how we calculate permutations. There's one different element with no repetitions. Take R elements each time from n distinct elements. That's just n factorial divided by n minus r factorial. Right? Two n distinct objects can be permutable by n factorial permutations. Alright? If we let n equals r in 1 we can get p of n comma n is just n factorial. Let's do example 1 now. In how many ways can the letters of the word math be arranged? I'll let you guys have a try in this question and tell me your answer to chat. Anyway, let's get started. So basically, there are we have 4 letters MATH and we have 4 blanks. Alright, we're trying to make any word. I can give you 4, 3, 2, 1. Alright? This is MATH. I mean, you have 4 choices. There's math for the first one. You have any choice to write for the first one. It's just four choices. Second one, there's three choices because we already choose another one letter. Two choices for the third one because we already choose two letters. And one choice for the last one. It has no choice. This just gives us 4 times 3 times 2. 4 times 3 times 2 times 1. It goes 24. No calculators. All right? No calculators. Okay? Just use your brains to calculate. And it's pretty simple. Pretty sure you can do the multiplication instead of just using a calculator. Right? Now let's move on to combinations. Let's first derive this formula. How do I derive the P of n comma r is equal to n factorial minus divided by n minus r factorial? Say we have we have six numbers, 1, 2, 3, 4, 5, 6. I have three blanks, all right? And how many numbers can we make with the six numbers that are not, all of them are not zero and distinct, and they are three. There are three. So let's say the numbers are 1, 2, 3, 4, 5, 6. We have these. I'm gonna make them smaller. We have these three. Right? 1, 2, 3, 4, 5, 6. Now there's three blanks we have. All right? Now, what we do is that, notice that 1, 2, 3, 4, 5, 6, we have six choices for the first one. Six choices. And we have five choices for the second one because we have six numbers already. One already has been chosen. And then we get five. And then multiply by 4 for the last one because there are four numbers left. All right? Now, how does this example get you the formula over here? Well, how do we think about this? Well, let's try to think it the opposite way. There are 6 factorial ways. What we're doing is 6 times 4 times 4 times 3 times 2 times 1. And we have to divide by 3 factorial. Why? Because this is basically the same as counting the arrangements of any three numbers, and we divide by 6 factorial. Alrighty? As you can see, this is just 6 times 4 times 4 times 5 times 4. So we're not including the last 3 or the last n minus r. So we're not including n minus r. So we're going to have to divide by n minus r factorial. So this is how you can generalize it to get n factorial divided by n minus r factorial is how many permutations there are. And we just proved it. Alright? Now let's move on to combinations. Combinations is basically the same proof, but then we have to divide by r factorial. And you'll see why. So what's the definition of a combination? We let n comma r be the non-negative integer such that 0 is less than equal to r is less than equal to n. Obviously, because we have we can't have a question saying I have n objects and I give you n plus 1 objects. How many ways I can do this? Well, we will have no ways because we only had n objects in the first place, right? It doesn't really make sense, right? And we use this notation right over here to read n choose m, or n choose r in this case. Well, this is just defined as or notated as p of n comma r divided by p of r comma r as n factorial times r divided by r factorial divided by n minus r factorial. And these are some tricks to remember. And since n minus r equals R. We have n choose R equals n divided by n choose n minus R. Alrighty? Now why do we have this? There's a really good method. So what do we do? Well, notice that this basically happens because they are symmetric. So think about it. Let's say we have three objects and we're choosing two. We have three objects and we have two others. Alright? Well, based on this definition, we should get 3 choose 3 equals 3 choose 1. Now notice that if we have three objects and we're choosing any one, there's three possible ways, right? But then we're basically separating this. Watch. Say I did one, I chose one and left two and three out. This is the same as choosing two and three and leaving whatever out. Alright? So we can do it for basically as a generalized form. It's just subtraction. It's just n choose r is equal to n choose n minus r. Alrighty? And these are just formulas to remember. Our reason why n choose factorial divided by r factorial times n minus 4 factorial, why we divide by another r factorial, is because we have r numbers left after we do the permutation. But in this case, combination counts because we use order does not matter. So we know there's r factorial for each permutation of r numbers. So basically, we have to just divide by r factorial to remove the permutations and just make sure order doesn't matter. Alrighty? And let's move on to example 2. In a group of 2 cats, 3 dogs, 10 pigs, how many ways can we choose a committee of 6 animals? Same exact thing. We just do add all of them up, which is just 15. And we each have to choose 6, right? Alright, so we're gonna have to calculate this. And if anyone wants to calculate it or they would love to without using a calculator, okay. So basically, this should give us to be 115,6. It's just 5,005. You do the math, you do the exact formula, and you'll get it. So the answer is just E. Alright? It's just gonna take time for calculating. Alrighty? So that's it for today's class. I hope you guys have a wonderful weekend, and I'll see you next week. Bye!